Hi folks, it's Alan here, and I'm back in my electronics cave, and I've just started to build out the final and most important stage of my Apex digital to analog converter, the actual digital to analog conversion stage. And the first part of this is actually, once again, digital circuitry. So I've taken some traces that show what's actually going on here. The bottom trace on that oscilloscope is actually the raw bitstream digital to analog signal, or the raw bitstream digital signal. The one above that, trace number 2, that's simply exactly the same signal but just reclocked. What I then do, however, is actually the bit that's really critical. You can see above it, trace 3, that's just a fairly consistent clock signal. And that's generated using this crystal and a lot of filtering and an extremely precise power supply to generate an absolutely exact 192 fs. So that's 192 times the original sampling rate. In this case, the sampling rate in the middle of my DAC is 352.8 kilohertz. So that's 192 times that frequency, round numbers about 8 and a bit megahertz. And what I then do is I AND the reclocked signal with that, and that gives me extremely precise timing. So here, the timing of this positive edge is only dependent on the timing of that signal and whether this is positive or negative. The timing of the falling edge is also only dependent on that signal and whether this is positive or negative. And you can see here that actually there's a small delay between when this signal goes high and when that clock pulse comes through. So this means that all of the critical timing, actually the timing on these bottom 2 signals here, I'm not terribly impressed by, because basically it's using third-party chips and they're fine. The timing, however, of this trace, the third trace, the clock signal, is perfect, which means the timing of the final trace, the top one, which is the all-important one that I'm now going to pass through my digital to analog converter stage, the timing of that is absolutely precise, down to the picosecond.